Welcome to our deep dive into the engineering marvels of ancient Rome, the aqueducts. Join us as we explore how these impressive structures were built, their impact on society, and the advanced technologies that made them possible, highlighting Roman ingenuity in water management. The genesis of Roman aqueducts. The story of Roman aqueducts begins in 312 BC with the commissioning of the Aqua Appia, the first Roman aqueduct, during the consulship of Appius Claudius Caecus. The need for aqueducts emerged as Rome's population expanded rapidly, outgrowing the capacity of local water sources like the Tiber River and nearby springs, which were insufficient and prone to pollution. Aqueducts were conceived as a solution to transport fresh water from distant, often mountainous regions directly into the bustling urban centers. This innovation was not just about meeting basic water needs, it was a strategic response to enhance urban living conditions, support public baths, and supply affluent households and vital industries. The construction of the Aqua Appia marked the beginning of a new era in urban infrastructure, setting a standard for future aqueducts that would sculpt the landscape of Roman civil engineering. Engineering marvels, design and construction. Roman aqueducts are celebrated as extraordinary feats of engineering. These structures were meticulously designed to transport water across vast distances using a gentle gradient that ensured a continuous gravity-fed flow. The Romans employed a system of precise surveying instruments, like the groma and chorobates, to achieve the necessary accuracy for these gradients. The construction of an aqueduct typically involved deep underground tunnels, towering bridges, and sturdy arcades that traversed valleys and navigated rugged terrains. Key to their durability and functionality was the use of advanced building materials such as waterproof concrete and volcanic stone, which were crucial for managing the immense pressure of flowing water. Innovations such as the use of lead pipes, known as fistulae, allowed for the efficient distribution of water within cities. Each aqueduct was an embodiment of Roman resilience and technological prowess, showcasing their ability to blend utility with grandeur, ultimately redefining the urban landscape of the ancient world. The major aqueducts, a closer look. Among the many aqueducts built by the Romans, some stand out for their engineering brilliance and the volume of water they transported. The Aqua Claudia, constructed during the reign of Emperor Claudius, is notable for its length and the purity of the water it delivered. Similarly, the Anio Novus, sourced from the Aniene River, was among the highest capacity aqueducts, serving the growing needs of imperial Rome. Each major aqueduct had unique features. For instance, the Aqua Marcia was celebrated for its cold and clear water, highly valued in the hot Mediterranean climate. These aqueducts not only supported daily life, but also facilitated the spectacular water displays in public baths and fountains, contributing to the city's social and cultural vitality. Water distribution and usage in ancient Rome. The management of water distribution in Rome was a sophisticated operation. Water rights were carefully allocated, with public needs such as baths, fountains, and latrines prioritized. Private households could also secure water access through legal agreements, often at a high cost. This structured distribution ensured that even during dry seasons, essential services remained operational. Aqueducts also supported industrial activities like milling and mining, showcasing their versatility. The network of lead pipes and stone channels within cities exemplifies the complexity of Roman water infrastructure, which was governed by strict regulations to prevent misuse and ensure the maintenance of public health and hygiene, reflecting the deep interconnection between engineering and legal frameworks in Roman society. Technological innovations and materials. The construction and sustained operation of Roman aqueducts were made possible through groundbreaking technological innovations and the use of novel materials. The Romans were pioneers in the use of hydraulic cement, known as Pozzolana, which is derived from volcanic ash. This material was integral to building structures that were not only strong, but also resistant to water. Pozzolana cement enabled the Romans to construct underwater concrete foundations and waterproof linings for their aqueducts, a revolutionary advancement at the time. Moreover, the Romans utilized siphons constructed from lead or stone to overcome geographical obstacles. These siphons worked on the principle of inverted siphoning to push water uphill over valleys and dips, a technique that showcased their deep understanding of hydraulic engineering. The strategic combination of these materials and innovative techniques facilitated the creation of aqueducts that could span hundreds of miles, ensuring a reliable water supply to urban centers across the sprawling Roman Empire. Impact on Roman society and beyond. The introduction of aqueducts had a transformative impact on Roman society, reshaping the urban landscape and influencing daily life significantly. These engineering marvels enabled the growth of cities beyond the capacities of their local water supplies, facilitating urban expansion and the proliferation of public baths, latrines, and ornate fountains that became central elements of Roman culture and public life. Aqueducts also played a critical role in public health and sanitation by providing a continuous supply of fresh water, which helped to prevent diseases associated with stagnant and polluted water sources. The availability of water supported various commercial activities and industries, such as agriculture, milling, and textiles, which contributed to economic growth and stability. Beyond their practical uses, Roman aqueducts symbolized the power and technological prowess of the Roman Empire. Their ability to control and manipulate natural resources on such a massive scale demonstrated Rome's dominance and organizational capabilities, leaving a lasting legacy that influenced engineering and architectural practices in later civilizations. This enduring impact is still visible today in the aqueducts that stand as monuments to Roman ingenuity and ambition. Maintenance and preservation of aqueducts. Maintaining the vast network of Roman aqueducts was an ongoing challenge that required a sophisticated organizational approach. The Romans established a specialized workforce, including both skilled laborers and slaves, known as aquarii, who were dedicated to the maintenance and operation of these water channels. These workers performed regular inspections and repairs to ensure the structural integrity and functionality of the aqueducts. Issues such as calcareous deposits narrowing the channels, structural damages from natural wear or sabotage, and illegal water tapping were addressed through meticulous care and strict legal measures. Additionally, the preservation of aqueducts was seen as a matter of state security and public health. Regular checks and balances were imposed, and severe penalties were meted out for any tampering with the water supply. This level of administrative oversight exemplified the Roman commitment to civil service and infrastructure, underscoring the importance of water management in urban planning and public welfare. Thank you for exploring the secrets of Roman aqueducts with us. These structures not only revolutionized ancient engineering, but also left a lasting legacy on urban development. Don't forget to like, subscribe, and share your thoughts in the comments below. Stay tuned for more historical insights in our upcoming videos.